All right, so this is Unit 3, Day 2. Unit 3, Day 2. And we're going to actually start doing proofs today. So we're going to just dive into a big thing in geometry, but we're going to practice it using something more familiar to us, which is algebra. Okay? So we're going to do algebra, but we're going to learn how to structure a proof as we're doing some algebra. All right? So that's why we're starting with something familiar to us. And we're doing this. All right. So does everybody see this on their paper? Okay. We're about halfway down from yesterday's notes. So when we do proofs, you can kind of see on that example below us. All right. You're going to make a table. On the left side of the table, we list the statements. Statements. So this blank is statements. That's basically from one step to the next. So on the left side of our table for our proofs, we're going to have our statements. On the right-hand side of our proofs, we're going to have what is called the reasons. Okay? So when we're listing our statements, we're going from here to here to here to here, but we have a reason for each thing that we do. Now, yesterday we learned a bunch of properties, right? They're right above you on your notes. Okay? So those can be some reasons. So what can we use for reasons? We can use properties, like I just talked about. Y'all fill in with me, please. We can use properties for reasons. We can use definitions for reasons. We can use postulates. And we're going to learn about postulates and theorems later. And we're going to learn, we can use theorems. So these could all be what we could use for a reason for our proof. In the reasons part of the table for our proofs. So the left side is our steps to explaining something. The right side is the reason for each step. Okay? Every proof you got. All right, so we're going to start proofs today by solving equations. Right? We're going to solve equations. Basic Algebra 1 stuff. Actually, you learned that in junior high and middle school, right? You've been solving equations since, what, 5th, 6th grade? Long time. Now, this example 1 right here, they solved an equation, didn't they? Okay, so your statements are going over here. I don't like that they didn't label that. So your statements are here, statements, and your reasons are over here. Now, in every proof, every single one that you're going to do for this whole entire class, your first statement is going to be what is given. They're going to give you something. So they say given 4x minus 1 equals 27. Prove that x equals 7. Okay? So your given will always be your first statement. And the reason for that is because it's given. So whatever you are given, that is your first statement, and you write given for the reason. That's what you're starting with. Okay? So your given is what you always start with. And then you solve the equation. Well, they solved the equation basically for us. Right? So we just got to figure out the reason or the property that was used on both sides to solve this equation. Okay? So from step 1 to step 2, what did they do to both sides of that equation? They added 1. If you want to fill them in the blank in between them, they added 1. So what property says you can add something to both sides of an equation? Addition property. So they got from step 1 to step 2 using the addition property. Okay, so we're just filling in the reasons right now. All right. So from then, when they did that, they were left with 4x equals 28. And they went from 4x equals 28 to x equals 7. So how did they go from step 2 to step 3? They divided both sides by 4. And so the last step to solving that equation was what property? Division property. So that's basically all you're doing. They have solved the equation for us, and we tell what property was used from each step to the next. Okay? Flip over to page 3 in that little section of notes. Let's look at number 2. Now this is pretty simple, so we might not do every one if that's okay with you guys. Because they're going to get to where it's a blank proof, and we have to do the statements and the reasons. Okay, so that's what it's coming to. So this one, the given is a over negative 6 plus 2 equals 5. So they copied that down on statement 1, and the reason for statement 1 is always given. Okay, so again, I'm going to write statements and reasons because it bothers me that they did not include that, because I want y'all to always see that on a proof. All right, so the first one is given. So they went from step 1 to step 2. Now, what did they mathematically do on both sides of that equation? Yeah, they got rid of that 2. They subtracted 2 on both sides, didn't they? And 5 minus 2 is 3. So this is subtraction property. Make sure that you write out the word subtraction because it could look like substitution if you don't. Okay? I'm okay if you abbreviate some things, but not subtraction and substitution. Okay? Because those are abbreviate to the same thing. And also don't abbreviate associative property for various reasons. All right. Ha, 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 ha. We don't want cuss words on our papers. All right. So we added, subtract 2 on both sides and got 3 over here. So now we have the equation a divided by negative 6 equals 3. So what did they do from step 2 to step 3 on both sides? Multiplied both sides by negative 6. And then they got negative 18, right? So that was what property? Dang it, Ryan. Multiplication property. And that finished the proof because I wanted to prove that a equals negative 18, and that's what we got when we solved it. So your very last step, whatever it says to prove, that better be your last line on your statements. Okay? All right. All right, let's do this one. We ain't gonna do all of them. Let's do this one. So here's our given. Negative 9 times the quantity 2x minus 3 equals 63. Prove x equals negative 2. First statement is what they give you, and the reason is given. All right, so we got to fill in the rest of the reasons. So what did they do from step 1 to step 2? Distributed. So I'm going to write distributive property. And I'm going to abbreviate a little bit. That's okay with y'all. As long as you give me enough letters to tell me what it is. And then they had negative 18x plus 27 equals 63. And then they went from there to this line 3. So what did they do from step 2 to step 3? Subtracted 27 on both sides, looks like, right? So that would be subtraction property. Again, we got to write out subtraction, unfortunately. And then they went from negative 18x equals 36 to x equals negative 2. What's the final thing they did on both sides? Divided. Division. How to sound it out? Property. Y'all see what we're doing? We're just writing down what property is used to solve the equation from one step to the next. Let's skip number 4. Okay. Let's look at number 5. All right, so number 5, there's the original given for step 1, and we said the reason is given. Then I went from step 1 to step 2. What did they do between step 1 and step 2? They distributed. We had parentheses to start with. Now we don't. They distributed, right? The distributive property. Okay, now this might be a little bit confusing. What did they do between step 2 and step 3? They combine like terms, right? Well, that's not really a property, right? So when you combine like term, you're adding and subtracting, aren't you? Right? So I think we're going to say that we added, right? Negative 7x plus 4x. If you put subtracted here, technically it's not wrong because you have a negative, right? So I'm going to say that's the addition property. Okay. So they combined like terms, and they went from this to this. What did they do on both sides to get that 12x over here. They did. So sometimes it helps if you like fill in the blank in between. Does that make sense? Sometimes that helps me. So they did subtraction property. I can't spell subtraction, apparently. All right. So then from step 4 to step 5, what did they do to both sides? They added 14, so that's addition property again. So you can repeat these. And then they went from negative 15x equals negative 10 to x equals 2/3. What did they do on both sides? They divided by negative 15, so division property. You see kind of how that goes? Okay. Well, that kind of completes that notes packet, but I got another one for us. Some more of these. So y'all can put that away, or you might want to keep it out for the properties, but if you know that's pretty good. All right, so this packet I'm handing out right now, it has, we're going to do some notes in here and your practices in here, okay? So it's everything, notes and practice. Now we bring down our GPO. 1, 2, 3, 4. All right. Y'all make sure everybody's got one. All right. Let me get to where we are. Day 3. Nope. Day 2. All right. Turn to the page. It looks like this. I think it's like the second page. Y'all see that? Y'all see that page? Yes or no? Yeah. It's the second page. Right? It says algebraic proofs at the top. Does everybody get to where I am? Anybody not know where I'm at? Okay. So, notice about these. What's different? What's different? Yeah, it didn't do the steps for us. So we've got to fill in the whole proof table by ourselves. Okay, that's what this is called, it's proof table. Okay, we've got to fill it in by ourselves. Now, y'all are lucky that I gave it to you on a handout. Otherwise, you're going to be writing out statements, reasons, and a T-chart on your own paper. Okay, so this saves us a little bit of headache. All right, it won't always be that way, so don't get spoiled. Okay, so when you're doing a proof completely by yourself, your first statement is the given. So given is 3x plus 1 equals negative 14. And that reason is going to be given. Now, sometimes your statements are numbered and sometimes they're not. I actually prefer them not numbered because when we start doing geometric proofs, you can do things in different orders. Okay? But this time we're just solving an equation. Okay? So each statement will be the next line of the equation. So if I'm solving this for x, and you know you're done with the proof, y'all, when you get to this. When you get to what it says to prove, x equals negative 5, then you're done with the proof. Okay? So when I get to this, and I write the reason for it, I'm done. Okay? So how do I solve this for x? Subtract 1 on both sides. So if you want to just like really tiny do that, if you have to show those steps to make sure you're straight, just kind of barely do it underneath that. Then you're left with 3x equals what number? Negative 15. Now, what was the reason for that? What did we do on both sides? We subtracted 1, so that would be the subtraction property. Okay, now how do we solve 3x equals negative 15? Divide by 3 on both sides, and we get x equals what? Negative 5. And what did we do on both sides? So division property. Is that what they wanted us to prove? Yes, that's my last statement. I have a reason for it, so I'm done with my proof. It's okay that I have an extra blank down there. Okay? So it's not always how many blanks you have is how many steps. Sometimes you actually need more blanks. Okay? So you can't go by the number of blanks every time. Sometimes they give you too many just to have room. Okay? But you're done. So that's what you're going to do. You're just going to follow the steps logically to solve the equation and writing down the property that you used on both sides over as a reason. Okay? Let's do number 2. We're not going to do all of these together, but we're just going to do a lot of them. Not a lot, but a few. I have them marked on here. So if you see the red star on the screen, those are the ones we're doing. So we're going to do number 2. So what do I write down for my first statement? The given. So 2 times parentheses, x minus 9 parentheses equals negative 10. And my first reason is what? Given. Your first reason is always given. So you should never, ever, ever on a test or quiz or anything turn in a blank proof to me. You can always do this much, right? Right? And if you have no clue what to do, you can go skip, 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 and put that there, right? And a lot of times that's half a proof. Okay? So never, ever, ever turn in a blank proof. You can always at least do this, right? Okay. Now, if I'm solving that for x, what will I do first? I'm going to distribute. So what's 2 times x? What's 2 times negative 9? Equals negative 10. And we did what property? Distributive property. Okay. And then how do we solve for x? Add 18 to both sides. And then we get 2x equals 8. And that was what property? Addition property. And now how do we solve for x? And get x equals, is that what I was trying to prove? Yes. And what was my last step? Division. Not so bad, is it? You can solve an equation, you can do this, right? Let's skip to number 6. Okay, this one has a variable on both sides, right? Y'all see that? So what do I write down for my first statement? 5n minus 42. Gosh, my pen is equal to 12. What the heck? Excuse me, trying to learn this pen. See, look. Equals 12n. All right, what's my first reason? Given. All right, I'm solving for n, but I have an n on both sides. Well, this n is all the way over here by itself, isn't it? Right? So I need to move this n, this 5n, to the 12n. So how do I do that? Subtract 5n on both sides. Everybody agree? And if I don't do it that way, I'm going to create a whole lot more steps, trust me. So what is 12n minus 5n? 7n. And what property would you just use? Subtraction. All right, now how do I solve this for n? Divide by 7. And what just happened there? It just erased a bunch of stuff. Jeez. Divide both sides by 7. Did y'all see that? Stuff is disappearing. I know. I got to figure out this pen. All right, so I'm going to get negative 6 equals n. Do you see how it's in that order? Right, because the variable's on the right-hand side. That's important. Okay. Division property. So you need to keep it. Don't just swap it around when you're doing a proof. Okay? Because we're wanting to prove n equals negative 6 with the variable coming first. Right? Didn't we learn a property yesterday that says we can swap the order? What property says we can swap the order of something? Symmetric. So we need to, since the variable we got on the right-hand side, we need to move it to the left. So we need to include that symmetric property in a step. Does that make sense? So don't just flip it. You literally have to list out every step on these. You can't skip steps. Even though we're good at equations by now, and we know -6 equals n is the same thing as n equals -6, you want your answer to look exactly what it says to prove. Does that make sense? Okay, this is not a skip test on whether or not you can solve an equation, because I assume that we all can. This is a skill on setting up a proof and do it with something basic for us. Does that make sense? So you have to list all your steps because that's what we're trying to do right now. Okay, we need to know why we swap the order is because of the symmetric property. Does that make sense? Okay, and we need to get used to whatever it says to prove. Our last statement has to be exactly the same thing. This is not exactly the same thing because it's in a different order, but we have a property that fixes that. Okay? All right, let's skip down to number 8, and this will be our last example for today. It's also our longest example for today. All right, so what do we fill in for our statements? Yeah, the given, right? They didn't even tell you it was given, but we know that's what's given, right? So 14 minus 2 plus 6 plus 8. And what's my first reason? Given. So your first statement, you copy the original problem, and your first reason will be given. Look at me when you're done, so I know we're good. I know y'all are geniuses and trying to work ahead. It's okay. What are we going to do first to solve this equation? Now, we're going to distribute twice, right? And you can go ahead and take, since it's the same property, you can go ahead and take care of that on both sides first. Okay, no, but what are you distributing over here on this side? A -1. Okay. So if you need to stick a 1 there to help you remember that. So I'm going to have 14 minus 2x minus 16 equals 5x minus 3x plus 34, because a negative times a negative is a positive. And y'all make sure I did that correctly. And what property did we just use? Distributive property. All right, any questions on that step? Now what do we need to do on both sides? Combine like terms. Well, on the left side, we got the constants 14 minus 16. So that one's subtracting. Stop it. Stop it. Okay, and over here we have 5x minus 3x that are like terms. I'm subtracting at the same time on both of them, right? So since it's going to be the same property, go ahead and do them on the same step. Does that make sense? Now, if they were different properties, then you would probably want to do one and then do the other. Does that make sense?
Once you do addition, you can also pick up 2x and instead move it over.
Because we cannot skip steps when we're doing proofs. You have to list a property for everything you do. Okay?
What I mean by that is if you use the addition, simply add it all together though. Like you could add negative, or you would plus the 2x.
We're not.
Add 5x and also add 3x.
Yeah, but these are combining like terms, which is a different step than crossing the equal sign. I mean, if this was just a regular problem, I wouldn't care, but this is a proof. So we have to list every single property. Like I just said, this is not to see if you can solve an equation. It's to see if you can do a proof. All right, so I'm subtracting on both sides, so I'm going to use subtraction property. All right, now I can get my x's together on both sides. So what's one thing I can, okay, now looky here. I want my variable to be on the left. Y'all see that? So even though I would prefer to add 2x on both sides, I know I'm going to have to use symmetric property to flip. So it might make more sense, since we're going to have variable on the left side anyway, to go ahead and move this 2x to this one. Does that make sense? Mm-hmm. And it'll just save us a line at the end. Because it looks like I'm going to run out of lines. So I'm going to subtract 2x. What's negative 2x minus 2x? So negative 2 minus 4x equals 34. And what did I just do to both sides? Subtraction again. Again, that's not how I would prefer to solve the proof, but since I'm proving it to be x equals negative 9, I need the x on the left. Then what? Add 2. So negative 4x equals 36, and that was addition, right? Addition. My handwriting's getting worse. And then what do I do to solve for x? Divide by negative 4, so x equals, is that what I wanted? Yes, and that was division. Okay, you're basically just solving an equation and writing down the property you use. Yes, sir.
The part where it has negative 2 minus 2x equals 2x plus 3.
Mm-hmm.
Would that be both addition and subtraction, since on the top, on the one on the left, we're kind of doing like the
You could do this way.
subtraction, and then on the one on the right, we're doing addition.
Okay, but what you do to both sides? I subtracted 2x on both sides. That's the property you use. It's not what you had to do to fix your signs, it's what did you do on both sides. Does that make sense?
Wait, I actually haven't done the bullet, never mind.
Okay, so what you do to both sides is the property you use. Does that make sense? No matter if they're positive or negative, it's what you carry to both sides. Okay? All right, so just takes practice. I know we are honor students and we're good at solving equations and we have our little tricks and we can get them done fast and accurately, but the point of today is listing your properties and completing a proof. Got it? So I know it's kind of like annoying that we have to skip steps or we want to skip steps and all that stuff. I know that, but trust me, it's a process because on Monday we're going to do segment proofs and then angle proofs and all that stuff. And then it's going to be more geometry driven. All right? Got it? So that's why we start with the algebra, because algebra is more familiar with that. Does that make sense? Because you've had years of practice of solving equations. All right, that's technically the end of the lesson, so we'll stop there for my recording.